sorry guys, it was really bad. Couldn't start anything. So if you show up and if you don't, what I'll do is I'm gonna go over some of the review questions from the review questions from the final fall 2017. And I am back here. Hopefully you guys can hear me. I'm gonna go to the internet and I'm gonna bring down the questions from the regions. Sorry, we took about 30 minutes to get started here. Well, now hopefully it will go smooth. Let's see when we have our website. Okay, I think we're almost there. Even the internet is it's having trouble today. So. Oh my goodness, not my day. All right, so we're gonna go here. Nice. I think last time we went to question number, I believe question number 20. We stop at question number 29. So let's do question number 30 to finish this exercise. Do I have 30? Yeah. Okay, so let's grab that. And then we're going to go back because the next one is hypothesis testing, and that we will do that in class tomorrow. Alright, so we'll do this one, which is appropriate for what we're learning. Let's make this a little bit smaller. Okay, and it says here, I hope everybody's here and is watching, and you can ask me questions by typing on the side. You can ask questions. Okay, so the data represent a sample of the number of home fires started by candles for the past 7 years in a certain city. Okay, so these are the number of fires started by candles for the last 7 years. So we should have 7 pieces of data. 1, 2, 3, 4, 5, 6, 7. So right away we notice that one piece of information is that the sample size is 7. This is the sample size. Sample size is 7. Okay, I don't think it's plural, it's just singular. Sample size 7. What else we have? We also have, let's see, check yourself that the sample mean is 7,447, and the sample standard deviation, it tells you clearly that we are talking about the sample piece of information. So this is a statistics that we explained last class. And the standard deviation, which is little s, is 1616. They're big numbers because these are big numbers. Okay, so now it tells me identify the variable in this setup. In other words, what is it that they are counting? And I'm going to probably write the answer there. Their counting is the number of home fires. Number of home fires. Okay, so that was easy. That is the variable. The next question is identify an individual in this. In other words, where are they getting the information? And it tells you it's in the past 7 years, right? So it's each information that they have here is a year. So a year out of 7. 1 year out of 7. Okay, so that would be question B. Okay, now we're going to go with question C. Find and interpret a 99% confident interval for the mean number of home fires started by candles each year. Assume a normal distribution. So that piece of information is very important to us. We're going to go to C. And they want a 99% confident interval. In order for me to understand that, I would draw a picture, and that will be normally distributed because it tells me that we are to assume that is normally distributed. 99 is in the middle, and then we have spaces on both sides. This space is 0.005, and this is also 0.005, right? So they're looking for this value. Now we have to decide if that is a t value or a z value in order for us to be able to find the interval, and this is the interval that we are looking for. Right? It says this confident interval. Find the confidence interval. So they're asking us to find that. All right. So we need to find definitely what is the value of the whether I'm going to use a t or a c value. So we know the x value, x bar value from here, 7,447 minus the error, and 7,447 plus the error. Now we need to find the error. To find the error, we first have to find if this is a z value or a t value. And I'm going to tell you that this is a t value, right? How do you know that this is a t value? Well, we don't know the standard deviation from the population, so definitely we're not going to go to the yes side. We're going to go to the no side. We don't know it, and we know that this is normally distributed. So if it is normally distributed, the answer is yes, then we use t value. So that's how I know from the map that I gave you before. So the formula is this one. So we need to use the calculator in order for me to find that. So we're going to use my other calculator that has the inverse, because we know the area. We're going to go to menu, and we're going to go to 2. We're going to go to distribution. We know that it's supposed to be a t. We know that it's an inverse, and we know it's supposed to be a variable. Now the area that we're looking is 0.005, and the degree of freedom is, let's take a look at what is the sample size. The sample size is 7, so the degree of freedom is 6, which is 1 less than n. Oops. And then we got 6 here, and we go and we execute the value, and we get the value to be 3.7074. We're going to use 4 decimals, so we have a better approximation. So this is 3.7074. Positive and negative, but we're going to use the positive one. That's going to be 3.774. The standard deviation is 1.616, and the square root of n is 7. So if you multiply these two numbers and then divide it by the square root of 7, you're going to get 2264.2. Now this number is going to be subtracted and is going to be added, and we're going to have an interval. And the interval that we're going to have, and if you subtract it from that side, you're going to get 4,782.8, and on the other side you're going to get 9,311.2. So we created the confidence interval for the mean number of fires in that city. Okay. Now we're going to move on to question D. Does the confidence interval, a 99 confidence level, this one, provide sufficient evidence? So we're going to be doing some hypothesis testing. Provide sufficient evidence that the mean number of home fires started by candles in this city is greater than 5,000 per year. Now we will have to open a little bit space here, and the question is if the mean, we said that the mean number of fire is greater. The mean is greater than 5,000. That's what it says here. The mean is greater than 5,000. Well, this is not true. The answer will be no, because the mean, if you notice here, the mean can be less than 5,000, or it could be more than 5,000. This would be less than 5,000. This will be more than 5,000. So definitely it's not going to be greater than 5,000 all the time. It's not going to be greater than 5,000 all the time. Right? Because you can see that there are some cases where you're going to get less than 5,000. So this is true for some cases, but it's not always true. So that makes it not acceptable all the time. Okay, I'm going to pause here for a moment, because then the rest of the questions, I believe question number 31, and let's see where we are. Question 31 and 32 and 33 and 34 are for hypothesis testing. Now I have a question for you. I will do those questions tomorrow in class, so I don't want to get it right now. So are there any other questions that you would like me to do? I see some people, a lot of people are watching, so this is a good opportunity for me to ask you if there's any particular question that would you like me to do. So I'm going to wait for a moment there and ask if anybody has a question. Okay, you can ask questions now. I'm going to leave that there, hanging there. Remember, you can always go back and watch some of the stuff that I've seen before, that I have recorded. Let me wait for a moment and ask if anybody has a particular question. Okay, no one has questions. That's great. Okay. Alright, if no one has questions, then maybe I will try to do question 19. Alright, so we do have a question 19, and maybe work our way up. 25, somebody says. Okay. So let's go back to 25. Alright, so let's see, delete that and say 25. Alright, let's find question number 25 is here. Let's copy that into our notebook. Okay, and now let's read the question to see. Okay, somebody wrote Shanfei Shu. You wrote in Chinese. I don't know. I don't know what that means. Alright, so the question says the volume of soft drink in plastic bottles is normally distributed. So that's a great way to begin this. The volume of soft drink in plastic bottle is normal random. It's a normal random variable. I'm sorry, with mean of 16 ounces and a standard deviation of 0.6 ounces. Okay, so we can begin writing that information someplace. We don't need that 25. Let's put that away. Let's put that away. And it says the volume of soft drink in plastic is normal random variable with a mean of 16. Now notice that it doesn't say it's a sample, it just says that the volume of soft drink. So we're assuming that that's mu, random with a mean of 16 and a standard deviation of 0 ounces. Okay. Alright, now question A says if one bottle is selected at random, find the probability that it contains more than. Okay, so we're gonna do this and we're gonna do that, and we know that the mean is 16 because it says here it's 16, and we need to find if it contains more than 15.A. Now 15.A, it's a little bit less than 16, so let's assume that it's in this position. And more than means that we are going to, okay, do that. That is more than 15.8 on a soft drink. Now in order for us to solve this process, we're going to go to the calculator. And I'm going to bring my older calculator because I can put it in. Alright, I'm going to use that calculator to answer that question. Alright, now we got to leave a little space there so that we know what we are doing. We're going to go to menu, we're going to go to 2. Now this is mu, they giving me this number. So we are going to assume that these are normal distribution, not T, it's normal distribution because we do have this variable. It doesn't say that it comes from a sample, so we assume correctly. We're going to go to NCD, and they're going to ask us what is the lower value here. The lowest value is 15.A, 15.A. Sorry. The upper value is infinity. This continues, so we're going to select a very large number, 10 to the power of 10, and that mimics infinity. The standard deviation, it was given to us, the standard deviation is 0.6, 0.6, and mu, it was given to us as 16. So we do have all those values, and actually, you know what, I'm going to copy these values onto my screen before I give the answer. And let's put it over here so you know what I did. Alright, so we're trying to find the area. So now I'm going to press execute, and the area is 0.63. Okay, so we're going to copy 0.63, the area here. This green area is 0.6. 63. That's the area. Now, the answer in the back of the exam has a number that is very close to 63. The reason why is because they're using tables. They're using a table from the back of the book. Here we're using a calculator, so it's more accurate. So this would be acceptable in the exam. All right. Let's move on to question B. Notice that we're using z values here. Now, a random sample. Here we're talking about a sample now. So different from this question when there was only one bottle. Here we're talking about 25 bottles. Is selected from a large quantity of filled bottles. Write down the sampling distribution of the sample mean. Give the mean and the standard deviation of the sampling distribution and compare the shape of the sampling distribution to the shape of the original distributions of some soft drink. So this is something that we have seen before, right? Now the sampling distribution is when we explain the central limit theorem, right? This is not one, but is the population divided into very large number of equal samples, right? And when the population has been divided into equal samples and we graph this, then what happens is that the answer is going to be normally distributed. So the sample means this distribution is going to be normally distributed. As the sample size increases, as we get better information, this is going to produce a normal distribution shape. It does not matter whether the original was normally distributed or not, but the samples are going to be normally distributed. So we're going to write that down, and we're going to say that the sample distribution, what is the question exactly that they say? Write down the sampling distribution of the sample means. Well, the mean is going to be the same. This is going to be a mean, which is x bar of all the means, is going to be the same as the distribution of the original mu. So that's not going to change. Now, what is the shape? The shape of this is going to be normally distributed. Using the central limit theorem. And now they're asking me for the standard deviation. The standard deviation of the sample, that's something that we need to discuss, and I don't know if you remember, this is a formula that should be placed in your sheet of formulas, is the square root of the population divided by the square root of n. In this case, n is 25. So we're going to get 16, because that's the, no, I'm sorry, not 16, it's 0.6 divided by the square root of 25. So now you should use a calculator to calculate that. Let's go to menu, let's go to 1, and we go 0.6 divided by, well, the square root of 25 is just 5. We don't need to put the square root down. And you're going to get that the standard deviation of the sample is 0.12, right? Is 0.12 because we took the regular one and divided by the samples. Okay. So now we answered the question B. We got the mean and the sample normal distribution. Find the probability that the mean volume of soft drink in the 25, so it's not on the first one, is less than 15.8. So the question is very similar to the one that we did before, with two exceptions. Okay, let's do our Okay. We know that by the sampling distribution, this is still 16. And now they're asking me find the probability that the 25 bottle is less than 15.8. 15.8 is still on that side, and now it says less than, so less than is this side. So when we do the calculator, we're gonna ask us to find the lower limit. The lower limit will be infinity, right? So we write minus 10 to the power of 10. The upper limit will be 15.8. Okay. What else do we need? They're asking us probably for the standard deviation. The standard deviation for the 25 bottles. This is the 25 bottles. We found it here. It's this number. We're not going to use for one bottle, but for the 25 bottles. And mu is 16. So we're going to go into the calculator, and the mean never changes, ZU. The mean never changes. It stays the same because the central limit theorem says that the mean of the population and the mean of the sampling distribution is the same. And I think we did some exercises in class to prove that. So now we're going to move this to this side so we can see the information. I'm going to go to menu, and now we are going to go to number 2. We're going to pick distribution. We're going to pick normal. We're not using T because we originally knew this standard deviation from the population. We're going to take that one, and the lower limit would be minus 10 to the power of 10, right, to pick a very large number. And the upper limit now would be 15.8, because that's how much we're going to get to, right? And the standard deviation would be 0.12 for the 25 bottles. And mu will be 16. So now we find that the area is 0.047. So 0.047, right? And that is the area, and that is the probability. Now, if you look at the answer in the book, it's going to be a different number because they're using a table. So the answer is never going to be exactly. We're using a calculator, so the answer will be much better. Okay, so let's leave that there for a moment so you can appreciate what we did. And we're going to wait for a moment, and we're going to ask if anybody really has a question based on what we did so far. So we can jump to any place in the final exam that you want me to answer. So let's just wait, see if anyone has a question. Okay. And we're just going to wait there for a second, and anyway, you can always go back and watch the video in case it was not clear. Hopefully the sound is okay. If anybody can just tell me if the sound is okay, I appreciate by saying sound is okay. For a second, look through the final review, and let me know if there is a question that you have concern. Okay, thank you. girasol. Okay, just go and look through the final and see if there's a question that you'd like me to do. Mhm. I'm gonna wait for a moment just in case you have a possible question, right? Ziyun, what question are you referring to? Are you referring to the same question that we just did? I would like to know, proportion is the same as possibility? No, proportion is like a percentage. Okay, 26, okay. So let's take a look at question number 26. I have to locate the question first on my book, and then we're gonna. Alright, so let's open question number 26 from here. Alright, I believe it's very similar to the one that we just finished. Let's see how similar it is. 26 right here. Okay. Alrighty. Okay, let's read the question and see if we can answer. Alright, the question says a large survey found that an American family generates an average of 17.6 pounds of glass garbage each year. Wow, that's a lot of garbage. Assume normal distribution with a standard deviation of 3.5. Now, notice that nowhere tells us that this is a sample, just as a large survey. So we really don't know that an American family generates. It's interesting. So for now, we're going to, and it also says standard deviation. We're going to assume that this is mu, and we're going to write 17.6. Then is normally distributed. Normally distributed, so that's fine. And the standard deviation we're gonna assume is 3.5 since I don't have a sample size. Okay, question A. What proportion of families generates less than 17 pounds of glasses garbage each year? So it does not tell us what is it doesn't tell you what is the possibility. It tells you what is the proportion, right? The proportion. But remember that the number that you write here is a decimal. If you want to change that decimal into a proportion, you will need to multiply that by 100. So basically it's the same thing as the possibility, except that you have to multiply by 100 at the end. So let's take a look. Now the mu is in the middle, 17.6. That's the one that was given to us, and the question is, what proportion of family generates less than 17? So 17 has to be somewhere here. I'm gonna write 17, and it says less than. So alright, so that's going to be less than. We are going to go to the calculator, and we are going to go to the calculator, and we're going to say that the lower limit here, the lower limit will be infinity. That's a very large number here. Minus 10 to the power of 10. The upper limit will be 17, because I'm going to stop at 17, right? We want to know what is the green area, basically. It's going to ask us what is the standard deviation, and the only one that we have is 3.5. And also it's going to ask us for mu, which in this case 17.6. Remember, I can change that to z values, and basically it would be the same thing. Okay, so let's go here. Oops, sorry. Okay, let's go to the lower limit is already there. The upper limit, we're going to say 17. We're going to say that the standard deviation is 3.5 and mu is 17.6. We're going to answer that. And the answer is 0.4319. So this area here is 0.4319. So if you look at the back of the book, it's going to be a little bit different because of one decimal. This is 2. So again, the reason is because they're using a table, and it's gonna be different, right? The table, yeah. Like I said, in the back of the answers, it's a bit different because they use a table. They're not using a calculator, so it's an approximation. So it's going to be 0.432, let's say, for us, right? This is an approximation, and the book, I think, is 0.4325. So that's because, like I said, they're using an approximation. Okay. Is the next question here? If a sample of 35 families is randomly selected, so you will do the same thing that we did here, with the only difference that now you have a family. The sample size is 35, so you're going to put the lower limit, still going to be 10 to the power of 10. The upper limit will be, what is the number that they're using? 17. The same question, except that the standard deviation that you will use this time is 3.5 divided by the square root of 35, and mu will be 16. We notice that this is the same whether it is a sample or if the whole population is 16, and you're going to find your answer there. If you use the table, it's just that the tables cannot give you the exact answer. They approximate more. The calculator uses more decimals, so that's why you get a better approximation. It doesn't matter if you use the table, if you use the calculator, it's fine. It's not a problem. At this point, it's not a big deal. Okay. So we're going to put that. That's the same. That's the same. That's the only one that's going to be different, which is going to be 3.5 divided by the square root of 35. So where's the square root of, sorry, I put not the square root of 35. You can actually enter the whole thing there, and the calculator will be this, give you that. And mu, oh, did I put 17.6 there? What is that? Hold on. What is 17.6, not 16? Sorry, made a mistake there. It's 17.6. So let's go back to the calculator. So that's fine, and it gives you that the proportion is going to be 0.155. Okay. In the answer there, it's they have a mistake there. It's not same. It's not going to be the same as A. It's going to be different because you're using a sample size of 35 families. So definitely, the proportion is not going to be the same. The answer is not going to be the same. It's going to be less. You have more. Okay, so we are correcting that. Remember, the back of the answers, they're not all correct. I found mistakes in the past, and that's another mistake. So please correct that. All right. Thank you, Rodriguez, for correcting, helping. Okay, so let's. By the way, in the book also they change it to z values, right? So that's, we don't have to change the z values. We do it the same way. We don't need to do that. Okay, so I'm gonna wait for a little bit and see if anybody else has a question. Let me wait and let's absorb that information there. Let me know. Okay, I'm gonna wait for a little bit while you guys absorb what I said. Okay, I'm gonna wait. Okay. So I'm waiting. Remember, when we do the calculator, you use more decimals. Maybe I take a little um, note here. I believe that the calculator change the value from 17 to some other number, and the way that they do is that they change this to z values, and the formula for the z value is x minus mu divided by the standard deviation. And if you do that, the answer that you're going to get, it's a little bit more complex than the answer that they have in the it's going to be let me write it there, negative 0.1714287. Now in the review, in the back of the review, they use only negative 17. So notice that they don't use all the other decimals, and that's a problem because the calculator uses all the decimals. So that's where you have a difference between the answer that they have in the back of the review and the answer that the calculator gives, you know. So that's why you see that discrepancy. So that's one of the reasons why it's not going to be exactly the same. Okay, I am going to give you a few more moments and let me know if you have anything there. Okay, so I'm gonna wait for a few moments.
Google Express is a shopping app with lots of stores like Walmart.
This video will be uploaded as soon as I finish the conversation with you guys here, and I and I finish, it will be automatically uploaded. Yes. So I am waiting for anybody else that would like to see any other question. We still have a little bit of time. So again, tomorrow we'll do the questions. You know, we will do a lot of the questions too. Unfortunately, I don't think from school I'm able to record. I'll try to do a local recording and maybe then upload that local recording into YouTube later at the house. We'll see. And Friday, we will definitely do more reviewing. So that's also comforting. So I notice that more people are coming on online right now. So I'm gonna wait for a few moments to see if anybody has, okay, if anybody also has a question. Any more questions? Okay. I am gonna waiting a little bit more. When you watch this, you can just fast pace these moments where I'm waiting. Okay. All right. I guess there's no more questions. That's great. Okay, Luisa, I'm waiting for you. Tell me if you have any questions. Okay. Rodriguez says question number 20. Okay, so you know what? So that we won't lose any time, maybe what I'll do is I do question 20 and 22, and I don't know what else I didn't do. Alright, let's do 20. Okay, 20 should be here. You know what? I'm gonna do 19, 20. I don't know if there's another question there. 25, I think I did already. 26 I did, 27. So I'm gonna start so we don't waste time for anybody who wants to. Let me do 19 because this is very simple questions, I believe, and it will be great for us. So let's do 19 first so we can verify the answers. Okay, and I know you didn't ask me for 19, but I'm gonna do it. Sorry. Height in inches, a basketball player has a bell shape. So right now, as soon as we hear that, we say bell shape, we do bell shape. Distribution with a mean of 72.5 and a standard deviation of 3.25. Notice that this doesn't say anything about samples, so we assume that these numbers refer to the population. Okay, a height of 79 inches is what percentile? 79 is bigger than 72, so they want to know basically what is the area, the percentile, right? The percentage. 79, so in the calculator, we're gonna go and we're gonna go that the lower limit is 79. The upper limit is infinity, positive, 10 to the power of 10. And the standard deviation is 3.25 because that's what they gave me, right? And the mu is 72.5. So we're going to find the area without using a table but the calculator. The answer, oh, sorry. Well, you know what? We made a mistake because this is what's the percentile. So is the other way around, right? Yeah, I noticed. Mr. Pineda is when they're asking for percentile, they actually want to know what's under that. That's percentile. I'm sorry. So that's a cute difference. The percentile is this. So basically, we have to do a, the lower limit is minus 10 to the 10, and the upper limit is 79. So we got to do this backwards. Minus 10 to the power of 10. The upper limit was 79, so it's going to be almost everything else remains the same. So it's going to be close 97.72, right? 97 point, so approximately 98 percentile. So in the back of the book of the review, they said that the percentile, it's approximately 98 percentile because it's very close to 97. Okay, I'm going to go to question number 20, and then I'm going to jump to 1, I guess. I think 1 is very long. So let's do 20, since it was asked to us to do 20. Okay. All right. Assume that the finishing times in the New York City in a New York City 10-kilometer road race are normally distributed. As soon as you hear that, you're allowed to do this. Normally distributed. I love the fact that it's normally distributed with a mean of 61 and a standard deviation of 9 minutes. Let X be a random selecting finishing time. Find X is greater than 72. So 72, it's here, and it's greater than 73. We have to find the probability. P means the probability. If we do A, the probability that it's more than 72. So we have to go into the calculator, and we're going to put the lower limit. Oops, maybe I should put it. Sorry. I'm going to erase it, and I'm going to put it over here, right? The lower should be 72. The upper limit should be 10 to the power of 10, because we're not changing to C values. The standard deviation will be 9, because it's only for one person. Let X be a random selecting one finishing time. And mu is equal to 61. So I'm not going to put it in the calculator. You can actually do that. Well, maybe I'll do it because I just remember you don't have calculators. Okay, so let's take a look on this side. Alright, so we're going to go and we're going to change the lower side to 72. I'm going to change the upper side to a very large number, 10 to the power of 10. And the standard deviation is 9. Mu is 61. We are using Z values. Okay, and the answer for number 20A is this area here, or that probability is 0, 1, 1, 1, because we're going to use only 3 decimals. Okay, so that's A. B, we're going to change colors. It's between 52 and 70. So that's, we're going to use the same picture, normally distributed, of course. And the mu is 61, and now it's between 52 and 70. Right? So we have to go to the left and to the right. And now the difference here is that they give us a very specific area between 52 and 70. So the lower limit will be 52. The upper limit will be 70. The standard deviation will be 9. And the mu will be 61. Okay. Let's exit here. So these are very specific values. 52 is the lower limit. The upper limit is 70. And everything else remains the same. So the probability is 0.6827. Probably in the book is a little bit different. 68. This one would be 0.6827. Very close to the book probably. And the last question, A, B, C, it says find P95, percentile 95. So they are giving us the area, so we have to do the inverse for that one. Alright, so P95 means that we have to have 0.95 here. So they're giving us the area, and they want to know this value here, this actual value. So in order for us to do that, let's use the inverse. Let's get out of here, distribution, normal, and we're going to use the inverse. And now this is left. This is the left, which is 0.95. The area is 0.95. The standard deviation is 9 and mu is 61, so that doesn't change. And the value would be 75.80. 75.80, and this is the value that will give you 0.95, right? You can check by doing the inverse of that. Okay, so I think we did that one correctly, and let's do one more, which is number 1. I believe that the other questions are very similar. 21, 20, 19, 20, and 21, 22, 23, they're all very similar. So let's see one that is different. Number 1. Okay, number 1 is here. So let's copy number 1 into our page. Okay. Okay, so let's take a look at this question. Okay, so let's go back to question number 1. And that was a request from one of the, I think it was Luisa, who wants to do number 1. Okay. The following group frequency table, this is a table, shows the annual amount of snowfall in inches in New York City for the past 135 winter seasons, starting from the winter of 1869 to 70. Okay. For this scenario, identify the following. What is the variable? The variable is the number that we are counting. And what are we counting here? Annual, it tells you, it shows the annual amount of snowfall. So that would be the answer for A. Okay, the annual amount of snowfall. For question B, who's the individual? Who's providing each information? And it tells you there. Not 135, but a winter season. 1 winter season, right? In other words, there are 135 winter seasons, 135 winter seasons, and each winter season is giving you the amount of snow, Okay. The population for that is 135 winter seasons. All right. It's 135. I should say 135 winter seasons. population size is 135. They're no more than that. Now, if you look at this, we have to see if it is shape of the distribution. So we got to see what is the shape of the distribution. If you look at this, the bigger numbers are here, and then you begin to see smaller, smaller, smaller numbers. So if you graph this, which you should graph it, okay, you will see on question number E. Okay, I'm not going to do a perfect graph, and I'm going to just do numbers here so I don't have to keep writing. I'm going to put 1, 2, 3, or maybe you know what, so you don't get confused, I'll put letters so that you don't, let's say this is A, this is B, C, D, E, F, G, H. So instead of writing 0 to 9.9, because it's not going to be a lot of space, I'm just going to write A, B, C, D, E, F, G, and we need to expand this just a little bit more, H, right? So these numbers are going to go, oh, I should have made this a little bit bigger. Let's say that they go every 10, because I don't have a lot of space. 10, 20, 30, 40, and 50. So let's do a little bit of bars. 9, this goes to 9. Okay, it's not going to be a histogram, it's just going to be a bar graph, which is okay. 38 is going to be probably up to there, right? So we do that. 41, it would be a little bit more than 40, so we're approximating that. 19 will be, sorry, let me take that off. So 19D would be somewhere here. E would be 15, so it's a little bit more here, probably. So we did this 10. It's a little bit here. Oops, no, that was really bad, sorry. 10 is something here. This is 2, so it will be here, and that's 1, so it will be there. So if you actually try to connect the midpoints of the bars, even though this is not a histogram, you can still see that the tail is going to be going that way. So we call this, if you do E, this is skew to where? This is the right, to the right. Okay. Perfect. So we did A, B, C, D, E. Is this variable discrete or continuous? Continuous is F. Discrete, if you want to think about it, doesn't use decimals. No decimals. And continuous uses decimals. So if you look at this data, it's the variable uses decimal because it's inches, amount of snow. So our answer would be continuous. Okay. Make a histogram or a bar chart. Okay, so I did it there. For that would be something like that because it tells you that you have a choice of a bar chart. Bar chart's much easier to do. A histogram, you know, you will have to put the numbers a little bit closer together, no spaces in between. All right, so that's question number 1. All right, so I am going to stop at this moment. We'll do more questions tomorrow in class. We'll do more questions on Friday, and hopefully you will show up on Monday, right, in the morning, where we can do more questions before your exam on Tuesday. So I'm gonna say goodbye here, and hopefully you will be able to go back to your to the video and be able to do more questions. So we're going to end this by exiting.